Good afternoon. We are Team First Principles. Our challenge is Challenge 12A, and we are building a lifecycle costing tool. Introducing the challenge, it was to build a lifecycle costing tool by using the initial cost plan as the base data. Service, maintenance, operating and disposal costs can be as much as 70% of the total lifecycle cost of an asset. So it's important that client is given that lifecycle costing appraisal so they can understand the long-term benefits of using more sustainable options, which can often be more expensive initially.
I really care about the environment, which means that I want to make it easier to build sustainably. At the same time, I also want to achieve my BREEAM credits. I really should be complying with the recommendations in the construction playbook. I really need some help. I know, I'll ask my project manager. Hello, Mr. Atkinson.
Hello, Mrs. Client. Of course, I'll get that life cycle cost exercise over to you as soon as possible. How am I going to do this? It's a huge exercise and she wants it today. I wish I had a tool that would help me produce this quickly. Don't worry. Meet First Principles Life Cycle Costing Calculator.
After studying the challenge and the data available, we narrowed our focus, still utilizing a web application and Power BI visualizations, but powered off Excel.
Here's our initial thoughts on the process flow that we sketched out. As you can see, the cost plan is ingested by a web application that goes into a SQL database. There are a number of tables within there that are all linked. That goes to a cash flow table that is the one that's linked to Power BI. That Power BI, which you'll see later, is then embedded into an HTML web page. And then that HTML web page is linked back to the SQL server with data being sent back, and in time will be able to be used for machine learning functions.
We deployed a web app using an Express Node server as the backend and HTML interface as the front end, with a focus on the user experience and the way that the user interacts with the system. Standard tools were adapted. All data needs to be approved before entry or agreed to be entered into the system. And there are multiple ways that can be done, either by uploading a pre-filled CSV file. As we can see, there's the data extracted from the CSV file that has been sent to the node server. A microservice architecture is being used so that every time a user inputs data, it is pinged to the server and the relevant return data is extracted from the back end and returned to the front end, thus ensuring a seamless user experience. As we can see, the user interface is very intuitive and covers all possible options and variations in the system. Finally, with all the data being in the front end already, it can be calculated.
So now whilst Tim's showing the back end, this is the front end, which we've developed on Power BI. So what we've done is once Tim's uploaded the data into the database, the Power BI links directly to the database. On the right-hand side, you can see a table where we've downloaded the data and is visible in Power BI to see how that's allocated against the minimum, maximum, and the median values. You can also select the inflation calculation, so go between 0 to 3, 4, 5%, and that's all cumulative. Also, you can change the building lifespan. So if you think the building's not going to last 50 years or it needs to last 35 years, you can do that and all the calculations changes. You can also view each year in more detail to see how the maintenance and running costs or the replacement costs are allocated. We've also included 3 buttons, the minimum, typical and maximum, to show you the difference between the 3 costs. And on the bottom of the dashboard, you can see what the delta is between the maximum and the minimum, which can be as high as 20% sometimes, which really shows the importance of trying to find buildings with a longer lifespan, which will ultimately save the client more money.
Some of the benefits this solution will provide are it is a quick financial commitment calculator. It allows you to make sustainable decisions, identify yearly life cycle expenditure, review the impact of different inflation rates, BREEAM credit compliance, and compliance with construction playbook recommendation.
Some ideas for further future expansion include developing a full should cost model tool, building a net present value function, add a carbon counting function, enable comparison of specific elements for carbon reduction purposes, and to expand to make it more global specific.
So that concludes the presentation, and we've had a number of questions in, which I'll answer now. The first one was, how can this solution be adapted and scaled up for longer projects? So in reality, that is already built into what we've done. The version you saw went up to 50 years, but in reality, it's just a simple piece of Power BI code that will enable us to take that up to 100 years, 150 years, whatever we want to. And in terms of the size of the project, that's already baked into what we've done. So it is quite flexible already. Question number 2 was, how can you convince managers and decision makers to take a longer term consideration when deciding project costs? And I think that this is where this tool really comes into its own. At the moment, if a QS does a cost plan, to do a lifecycle cost on top of that is a separate commission, a separate piece of work that can take time and money. And often clients won't have that money to pay up front. With this tool, you'll be able to do it almost simultaneously and give the client that advice early on so that they can make those decisions looking at the long-term issues and the long-term cost benefit on the project. The fact that we're going to be making this a free-to-use tool means that it won't just necessarily be people within one company that could use it, it'll be for the industry to use. And we see this in the future. The more that people use it, the more data that it retains, the more we can train machine learning models to start predicting things like running costs, maintenance costs, inflation rates a lot better, and then the tool becomes ever more powerful. And number 3, what are the challenges of the commercial sensitivity of data? Well, you would have seen in Tim's section that as you enter the front end, you have to tick a box to accept that your data is being uploaded. So that's the first part. And then the second part is that once it gets ingested into the tool, it's all anonymized at that point. So even though we can be using the data, nobody will be able to trace it back to the origin. And then thirdly, this is all going to be built within the Microsoft Azure environment. So all the security that comes with that is built in. So there's no sensitive personal data there in terms of GDPR compliance.